Hello friends, welcome to this third video on random processes. This video will cover problems under the category of WSS, the wide sense stationary process. And in particularly, we are going to do problems under discrete nature. Come on, we will quickly move on to the problem. The problem is like, if x of t is equal to y cos t plus z sin t for all the values of t, here y and z are going to be independent binary random variables. Each of them assumes the value -1 and 2 with probability 2 by 3 and 1 by 3 respectively. We'll have to show that x of t is a WSS. So what we have been given, the first thing to be considered is x of t is going to be defined as y cos t plus z sin t, which is going to be our random variable. Y and z are my random variable. And what is the nature of y and z? Y assumes the value -1 and 2 with probability of y being 2 by 3 and 1 by 3. And also z assumes the value -1 and 2 with probability of z taking the value 2 by 3 and 1 by 3. So y and z are discrete random variables. Now what is the thing which we need to prove? We need to show that x of t is going to be a WSS. So we will quickly recall what is meant by a WSS, that is wide sense stationary process. What are the two criteria to be satisfied by a WSS process? The first condition is that your mean has to be a constant. So condition number 1, I'll have to prove that E of x of t, the mean of the random process, is going to be constant. The second condition which I need to prove for a WSS is R of T1, T2. This is nothing but our autocorrelation function. How do we define our autocorrelation function? The expected value of product of two members of the random process. And now, when you compute the autocorrelation, the final answer must be a function of tau. What is tau? Tau is nothing but time difference between the two members. That is T1 difference T2. This symbol is called as difference. So it is always the bigger number minus the smaller number. So how do you denote this subtraction by? To denote the subtraction by tau. The final answer must be a function of tau. So if these two conditions are satisfied, then I can claim that the process is going to be a WSS process. So we will begin with the first condition. What is our first condition? We will try to show that mean is a constant. So what we are going to do first to show mean of the constant. Okay, how to compute mean? Mean is nothing but expected value of x of t. So this is expected value of what has been given about x of t. Our x of t has been given as y cos t plus z sin t. So you refill this as y cos t plus z sin t. So this is my input. Now when I take the expectation to the input, what happens? We'll have to recollect the property of expectation that E of Ax is A times E of x. What is the role of A? A is the constant. What is the role of x? X is my random variable. You need to keep in mind expectation will be applicable only to the random variable and constant is not affected by the expectation comes outside. Now which has been defined as the random variable for us? Y and z are the independent random variables for us. So expectation will be applicable only to my y and my z, and the remaining quantity which is cos t and sin t will be treated like your a over here, and so a constant comes outside leaving you with expected value of y plus sin t comes outside leaving you with expected value of z. So my next target is to compute what is going to be expected value of y and expected value of z. How to compute it? We know that y takes the value minus 1 into and 2 with probability 2 by 3 and 1 by 3. We will quickly recollect that the expected value of y for a discrete random variable, this is discrete because it takes only finite number of values, summation y into probability of y. So what will happen now? The first value taken by y will be equal to minus 1 and the corresponding probability of y will be 2 by 3 plus, because we have a summation, the second value taken by y is going to be 2 and the corresponding probability of y will be equal to 1 by 3. So this gives me minus 2 by 3 plus 2 by 3 which is equal to 0. Therefore, what I have found now, e of y happens to be equal to 0. So go substitute e of y as 0. Now, what about the variable z? Random variable z also takes the same value minus 1 and 2 with the same probability 2 by 3 and 1 by 3. So this implies e of z will also be the same 0. So go substitute it over here. E of z turns out as 0. So what we are getting now? Cos into 0 is 0. Sine into 0 is 0. So finally what we have is mean is 0 and we know that 0 is an constant. Hence what we have proved? The mean of the random process is a constant. So over here my criteria 1 is proved. Mean has been proved as constant. What is the second thing I need to prove? I need to prove r of t1, t2 must be a function of tau. So we will try proving the second part. My second part is r of t1, t2. So this is expected value of x of t1 product x of t2. What is my x of t? My x of t is y cos t plus z sin t. So what will be x of t1? Wherever I have t, replace it with t1. So this will become y cos t1 plus z sin t1. What will be x of t2? Wherever I have t, replace it with t2. So this becomes y cos t2 plus z sin t2. So now this will now be equated as x of t1. So this is my x of t1, y cos t1 plus z sin t1. So this is my first member. Product with x of t2. What is my x of t2? Y cos t2 plus z sin t2. So I'll have to take expected value to the product of this term. So now let me expand this product. What will happen on expansion? Y cos t into y cos t gives you y square cos t1 cos t2. Next, y cos t with z sin t2. So this will become y z cos t1 and sin t2 plus the third term z sin t1 with y cos t2. So z y sin t1 cos t2. Next, z with the z gives you z square sin t1 sin t2. Now, this product has given us 4 terms. Let us expand this expectation. Since by linearity, I can make it as 4 different terms. So, this will become expected value of y square cos t1 cos t2, expected value of yz cos t1 sin t2 plus expected value of yz sin t1 cos t2 plus expected value of z square sin t1 sin t2. Now, we will have to simplify these 4 expressions. How to simplify? We will get back to the original data. What is given in our original data? Y and Z are independent random variable. Okay, what they have been given? We have been given Y and Z are independent random variables. So what do you mean by independent? Y can act separately, Z can act separately. In which case, what will be E of YZ? E of YZ can be written as E of Y product E of Z. So this will become separate component since it is going to be independent in nature. Now, what do we know about E of Y? From our previous stage, we know that E of Y is 0 and E of Z is 0. So, this gives me 0 into 0. So, expected value of YZ turns out as 0. Now, let us go and apply this condition to our previous stage. What happens? When I take expectation, it is only for the random variable. This cos t1 and sin t2 comes outside. So, what is expected value of YZ? This will become equal to 0. Similarly, over here, E of YZ sin t1 and cos t2 are constant. Expected value of YZ? What is expected value of YZ? This will also become 0. So, we will just be left out with two quantities, E of Y square cos t1 cos t2 plus E of Z square sin t1 sin t2. So, we will be left out with E of Y square cos t1 cos t2 plus E of Z square sin t1 and sin t2. Now we know that cos t1 cos t2 is constant. So it comes outside, leaving the expectation for only the random variable. So you have E of Y square. Similarly, sin t1 sin t2 comes outside, leaving you with expectation of just your E of Z square. So my next target is to estimate E of Y square and E of Z square. How to get my E of Y square? This is nothing but summation Y square into probability of Y. What do we know about Y? Y takes the value -1 and 2 with probability of Y being, what is the probability of Y? 2 by 3 and 1 by 3. So what we have over here is Y square into probability of Y. The first value taken by Y is -1 the whole square and the corresponding probability of Y is 2 by 3 plus, what is the next value taken by Y? It is going to be 2 the whole square into corresponding probability is 1 by 3. So I have this as 1 into 2 by 3 plus 2 square makes it as 4 into 1 by 3. So I have 2 by 3 plus 4 by 3. Since the base is the same, this will become 3. So my numerator can be added as 2 plus 4. So that makes it as 6 by 3. And this 6 by 3 can be simplified as 2. Hence, I have the value of E of Y square to be equal to 2. Now, what can be said about E of Z square? Now, Z also takes the same value, -1 and 2, with the probability of Z being 2 by 3 and 1 by 3. So, when I do the same process, what is E of Z square? This is again equal to 2. Now, go substitute this quantity back in your equation. So, this gives me cos t1 cos t2 times of 2 plus sin t1 sin t2 times of 2. So now what happens? 2 comes outside, leaving you with cos t1 cos t2 plus sin t1 sin t2. Now the time to recollect the formula of trigonometric identities. Now we have a quantity of the format cos A cos B plus sin A sin B. So what will happen to the next stage? I have cos A cos B plus sin A sin B. This is nothing but equal to cos A minus B. So high time we will have to recollect the formula. What is the formula? Cos A cos B plus sin A sin B equal to cos A minus B. So what will happen to my stage? This value cos A cos B plus sin A sin B. What will this now give me? This will now give me the value as cos of A minus B. What is A? T1 minus what is B? T2. So this becomes 2 cos T1 minus T2. And what do we know about time difference? T1 minus T2 can be expressed as tau. So my final answer will be equal to 2 cos tau, which is a function of tau. Hence what we have proved, the first condition what we proved was mean is a constant, and the second condition we proved that autocorrelation is a function of tau. Hence, since both the conditions are verified, what do we finally conclude? We finally conclude that x of t is going to be a WSS process. That's it. Quickly recollect. First thing to prove, mean is a constant. Second thing to prove, autocorrelation is a function of tau. Discrete random variable. So you take summation y into p of y for your e of y, summation y square into p of y for your e of y square. Since the value turns out to be 0, mean turns out to be 0. And now when you have autocorrelation, expand it, get that 4 terms. We know that y and z are going to be independent. If they are independent, e of y z can be expressed as e of y into e of z. Since both of them are 0, e of y z vanishes. So taking the common term outside, computing e of y square, you get the final value as 2 cos tau, which is a function of tau. Hence, we prove that the given x of t is a WSS process. Thank you.